Welcome to your Algebra 2 10.6 lesson on binomial distributions. First thing we need to do is define something called a random variable. A random variable is a variable whose value is determined by the outcomes of a random event. So for example, when you roll a fair six-sided die, you can define a random variable x that represents the number showing on the die, what it lands on. So for a probability distribution for that random variable, or for any random variable, each possible value for x must be given, and a probability for each of those values of x must be given, and the sum of the probabilities must equal 1. So for our example of rolling a fair six-sided die, all of the possible values for x are 1, 2, 3, 4, 5, 6, and the probability of each one of those outcomes is 1/6. If you add all those probabilities together, you'll get 6 out of 6, which is 1. Okay, so we're going to construct a probability distribution. We're going to do a table and a histogram based on the following problem. Let x be a random variable that represents the sum when two six-sided dice are rolled. Make a table and histogram showing the probability for x. Okay, so we have our sample space here. We've got the outcome for dice number 1, or actually die number 1 and die number 2. So if you look the way it's arranged, 1 plus 1 is 2, 2 plus 1 is 3, 2 plus 2 is 4, 2 plus 3 is 5, and so on. Okay, so we will use that to help us. The possible values of x are integers from 2 to 12. The table shows how many outcomes of rolling two dice produce each value of x. So then we'll divide the number of outcomes for x by dividing 36 to find the probability of any given value of x. Okay, so first thing we do is we make a table where we've got x, our values for x, the sum. Okay, so we have all the possible values, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This second row here is kind of optional, but it's helpful in a situation like this. Go ahead and write how many outcomes give you each sum. So one outcome gives us 2, 2 outcomes give us 3, 3 outcomes give us 4, 4 outcomes give us 5, 5 outcomes give us 6, 6 outcomes give us 7, 5 outcomes give us 8, 4 outcomes give us 9, 3 outcomes give us 10, 2 outcomes give us 11, and 1 outcome gives us 12. So now we're going to take each of those numbers of outcomes and divide by 36 to get the probability of getting that value for x. So the probability that x is 2 is 1 out of 36. The probability x is 3 is 2 out of 36, which reduces to 1 out of 18. The probability of 4 is 3 out of 36, which reduces to 1/12. The probability of getting a sum of 5 is going to be 4 out of 36, which reduces to 1/9. The probability of getting a sum of 6 is 5 out of 36, which does not reduce. The probability of getting a sum of 7 is 6 out of 36, which reduces to 1/6, and just continue on doing each number of outcomes out of 36 and reducing as possible. Okay, so the next thing we're going to do is we are going to make a histogram. Now, for the histogram, you want to think through, all of these were done as number of outcomes out of 36. So that's going to be useful in deciding our vertical axis labels. So we're counting by 36. So 1/36, 2/36 is 1/18, 3/36, 4/36 is 1/9, 5/36, 6/36 is 1/6, and then 7/36 would be up here, but we don't need that. Okay, our largest probability here is 1/6. And so we list the sums of the dice. So we have 2, 3, 4, and those go across the horizontal. And then the bars for our histogram are going to go between the two values. So here, this would be between 1 and 2 here, to between 2 and 3, and then between 3 and 4. So here's our bar for 2, here's our bar for 3 and 4, so on. And so you just look and go, okay, the probability of 2 is 1/36, so that's going to go here. The probability for 3 is 1/18, so that's going to go here. The probability for 4 is 1/12, so that goes up to here. That was 3 out of 36, so 330 out of 36 would be right here. And then the probability for 5 is 4 out of 36, or 1/9. Probability for 6 was 5 out of 36, so that's going to go right here. Probability for 7 was 6 out of 36, or 1/6, so that's up here, and then you just continue on to show the whole histogram. Okay, so using this distribution, what is the most likely sum when rolling two-sided dice, and what is the probability that the sum of 2 dice is at least 10? So for the answer to A, you look for the value on the histogram that has the tallest bar. The probability is greatest for x equals 7. It has the tallest bar there. Okay, so it has the largest probability of 1/6. And so that is the most likely sum when rolling 2 die. The probability that the sum of the 2 dice is at least 10, that's going to be the probability that the sum is 10 plus the probability the sum is 11 plus the probability the sum is 12. So you just add those 3 probabilities together. So 3 out of 36 plus 2 out of 36 plus 1 out of 36. You could start off with 1/12 plus 1/18 plus 1 out of 36, but you're going to have to get a common denominator anyway. And so you end up with 6 out of 36, or 1/6. Which is about 0.167. So about 16.7% of the time, the sum will be 10 or greater. Okay, so now you have some guided practice. Go ahead and pause the video and do those. As always, we will go over those in class. Let's learn about a binomial experiment. A binomial experiment meets the following conditions. There are n independent trials. Each trial has only 2 possible outcomes, success and failure, and the probability of success P is the same for each trial. So the probability of failure would then be 1 minus P for each trial. All right, when we're doing this is called the binomial distribution. The probability of K successes, okay, out of n possible trials is going to be n choose K. Remember our little formula for calculating combinations? Well, we're going to need that to count how many ways we can get K successes out of n trials. Okay, and then for those K successes, we need to multiply by a factor of P, the probability of success for each one of those. So we're going to have P to the K, and then that means you have n minus K failures, so we're going to have another factor of 1 minus P to the n minus K. So we're going to construct a binomial distribution. According to a survey, about 41% of U.S. households have a soccer ball. Suppose you ask 6 randomly chosen U.S. households whether they have a soccer ball. Draw a histogram of the binomial distribution of your survey. Okay, so our probability of success is going to be 0.41. Our probability for failure will be 1 minus that. N is 6 because we're asking 6 households, and it could turn out that either 0, 1, 2, 3, 4, 5, or 6 of those households actually have a soccer ball. All right. So we're going to go through the probability that K is 0 is going to equal 6 choose 0 times 0.41 to the 0 power. 1 minus 0.41 is 0.59, so then 0.59 to the 6th power, and then we'll estimate to 3 decimal places, so that's going to be 0.042. You go through, you do the same thing with K equals 1, so you have 6 choose 1 times 0.41 to the 1st power, these two always match, times 0.59 to the 5th power. You can always do n minus k to get how many you're going to have right there, and that's about 0.176, and we continue to do that for k equals 2, k equals 3, k equals 4, k equals 5, and k equals 6. Okay, there's also a really handy-dandy kind of thing on your calculator where you can use what's called binomial PDF, and you could just tell it what n is, what k is, and then what your probability of success is, and it will give you each of these probabilities, and I will show you all that in class. All right, so now we're going to make a histogram. So you just scale it appropriately. Here, each bar is 0.05, so here's 0.1, 0.2, 0.3. And you have all your possible outcomes, 0 through 6, and that's the number of households that have a soccer ball, and here's the probability of them occurring. And you draw the bars to the height of the appropriate probability using what you just found. Okay, so we're going to use that binomial distribution in example 3 to answer each question. What is the most likely outcome of the survey? Do you remember how to do that? You look for the tallest bar, and that will tell you which one is the most likely to occur. And then what is the probability that at most 2 households have a soccer ball, and we will calculate that. Okay, the most likely outcome of this survey is the value of k for which p of k is the greatest, which one has the tallest bar. This probability is greatest for k equals 2, so the most likely outcome is that 2 of the 6 households have a soccer ball. And if we go back and look, you can see 2 has the tallest bar. Okay, so now we want the probability that at most 2 households have a soccer ball. And so we want the probability that k is less than or equal to 2, because at most means 2 or fewer. So we're going to have the probability k equals 2 plus the probability k equals 1 plus the probability k equals 0. There is another cool command on your calculator that will will find the individual probabilities for you and add them up, and that's binomial CDF for the cumulative distribution function. But we'll use the values that we've already found here and just do 0.306 plus 0.176 plus 0.042. Where did we get that? Remember, we just calculated those right back here. Okay. So it's these 3 at most 2 is going to be the sum of those 3 values. So you add them up, and you get about 0.524. So a little over half. All right, so now you just have some guided practice to do on your own. And pause the video and then come back when you're done with that. Okay, last thing we're going to discuss is symmetric and skewed distributions. The shape of a histogram is frequently described as either symmetric or skewed. You can draw a vertical line through a symmetric distribution that will divide the distribution into 2 mirror images. So this right here is a symmetric distribution. If we draw a vertical line right here in half and we folded the one half over the other, we would have mirror images. In practice, we still consider a distribution roughly symmetric if there's some little slight differences, but essentially you want mirror images. Left skewed and right skewed occurs when you have a distribution that's not symmetric, but also it has a tail trailing off in one direction or the other. The direction of the skew is the direction of the tail. So on this particular histogram, the tail goes to the left, so this is left skewed. On this histogram, the tail goes to the right, so it is right skewed. All right, so let's classify a couple of distributions. So we're going to describe the shape of the binomial distribution that shows the probability of exactly k successes in 8 trials if a equals 0.5 and b if the probability of success is 0.9. And so we're going to provide you pictures of the distributions. So you just need to be able to look at a picture and tell whether it's symmetric or left or right skewed. So when the probability of p is 0.5, okay, probability of success is 0.5, we can see here we get a nice distribution that if we draw a vertical line right here through the 4 on up, we would have mirror images. So this is symmetric. For part B, on this one, there is definitely not a vertical line that we can draw where we're going to get mirror images, and in fact there is a tail trailing to the left, so this one is left skewed. The distribution is not symmetric about any vertical line, and the tail trails to the left, so that gives us the direction of our skew. Okay guys, that is it. So we will go over the guided practice in class, and that's all you have to do today. So I hope you have a good rest of your day, and I will see you in class soon.